Do you know how to make ice using steam? This is a copper pipe with one end sealed by a valve. If you connect it to a piston, then when you compress the gas inside the piston, the copper pipe will heat up rapidly. Congratulations, you have discovered the first law of thermodynamics. Compressing air causes air molecules to collide violently, making the temperature rise rapidly. If you use a fan to blow at the copper pipe, the heat on the pipe will be blown away and the temperature will drop. Pay attention, here comes the key point. At this moment, the gas inside the copper pipe changes from high-temperature, high-pressure gas into normal-temperature, high-pressure gas. If you connect another copper pipe on the other side of the valve and also connect it to a piston, then when you open the valve switch, the high-pressure, normal-temperature gas will rush from the valve into the copper pipe on the other side. Because the pressure suddenly drops, the normal-temperature, high-pressure gas will immediately become normal-pressure, low-temperature gas. And the temperature can even drop below 10 degrees. If you change the copper pipes on both sides into spiral coiled shapes, then you can obtain low temperature gas more efficiently. But if you want to get ice cubes, this temperature is still not low enough. So the clever you replace the air with ammonia gas. After continuous compression, the high temperature, high pressure ammonia gas is cooled by the fan into liquid at around 40 degrees. At this moment, when the valve is opened, the high-pressure liquid ammonia will immediately vaporize into gas and absorb a large amount of heat, and the temperature can drop below zero. If you place the second half of the copper pipe into a water tank, then the heat of the water will be continuously absorbed, eventually turning into ice cubes. But ammonia gas is toxic, so to prevent leakage, the clever you used copper pipes to connect two pistons together and replace the pistons with these valve-equipped cylinders. When you pull the piston upward, the intake end opens and the exhaust end closes, allowing the cylinder to suck in ammonia gas. When you press the piston downward, the exhaust end opens and the intake end closes, and the ammonia gas will be compressed and delivered into the copper pipe. Then you replace this valve with an extremely thin copper tube. The diameter of the small copper tube is only a few millimeters. After the high-pressure ammonia gas dissipates heat and turns into liquid, when passing through this small copper tube, it will squeeze against itself and maintain a high-pressure state. But when it flows from the small copper tube into the large copper pipe, the pressure will instantly release, continuously absorbing heat and making ice cubes. If you integrate this whole device into a small box, then congratulations, you have invented the earliest ice maker.